Hello everyone and welcome back. We'll continue our discussion on text analysis. So far we have seen feature extraction, and you can check out the documentation about feature extraction on scikit-learn. We have seen that in order for our algorithms to work, we have to first convert our data into a number format. And we saw various methods for that. We looked at count vectorizer, and we saw some terms like token, tokenizing, and counting. And we called the overall process vectorization, which is the process of tuning a collection of text documents into a number format. And that strategy is known as bag of words or bag of n words representation. So you can read more about it in detail in this document. Okay, so I'll go back to our Jupyter notebook and show you one more thing. Let's see the type of train text documenter matrix. Train text documenter matrix. And we saw that it's a matrix, a sparse matrix. And one more thing I want to show you is if we try to print our train text documenter matrix and run it, here we'll see the position of each of our words. Okay, so this 01, 02 represents the row index position and the column index position. Okay, so when we work with the sparse matrix objects, what we store is the position and the number of occurrences of our words, only the non-zero values. Okay, that's why we have 1, 1, 1, 1, 1, 2. We don't store any of the zeros. So 0, 0, 0, we don't store them. Okay, that's one thing to remember about our sparse matrix objects. Great. Next, let's look at an example. So previously, we trained our model on these features, right? So these are the features that we extracted from the given document set. What we'll do next is consider a different document set. And let me save our document in a variable called test text. So let's take this document for example. And what we'll do next is convert this document into a documenter matrix and see what we'll get. Okay, so if we take our vector object, our count vectorizer, and then call the transform method, and then pass this test text document, test underscore text, and let's save this in a variable called test text documenter matrix. Okay, so we are converting this text document into a documenter matrix. Now let's convert this test text documenter matrix object into an array by calling the toArray method. Okay, what do you think we'll get when we run this? So our document is first converted into a documenter matrix, and then an array representation of a documenter matrix will be printed. So what we'll get is an array format. Let me run it and show you. So here we got the result 01, 0, 1, 1, 0, 0. If you remember, we have trained our model previously on these 7 words, right? We use the 7 words to train our model. So anything that we pass that is not represented by any of these words will be dropped. So for instance, here in our test text document, the word don't will be dropped. That's because our model doesn't know anything about the word don't, because we haven't trained on it, right? There's no don't in here. So that's what it does. Since we trained our object on this our model on this 3 by 7 sparse matrix, the first thing it does is drop any words that it doesn't know or recognize. In this example, the word don't will be dropped. And the second thing it does is it makes sure we have the same length of features, right? So that's the transform method. It transforms so that we have 7 features as a result. Okay, that's why we have the 7 0 1 0 1 1 0 0. Okay, let's convert this into a data frame and show you. So pd.data frame, and then we'll pass our test text document term matrix into an array object. We'll pass that, and for our column names, we'll pass our vectors get feature names. So we'll pass, let me copy this, our columns get feature names, copy it and paste it here. Now let's run it. Oh, I copied columns twice. Let me remove this, run it again. Okay, there you go. So we have cab, go home, play, soccer, take tonight. Those are the same features as we trained our model earlier, right? And here our document, we only have one document. That's why we have one row here. And then we represent the words and then check the occurrence of the words. So soccer is in our feature and it appears once, so you see a count of 1. Don't doesn't appear at all in our features, so the word don't is dropped. Play appear once, so we have a count of 1. Go appears once, so here we have a count of 1. So any consecutive test document that we pass will be first converted into a document term matrix, and then all the words that are not recognized will be dropped because our model doesn't know about those words. Okay, let's look at one more example. Okay, next let's consider this test document. So we have 4 documents. Soccer, don't play, just go home, and then hey, I hope to see you all in the soccer game. And then we have the game was awesome, he scored at the end and won. And finally we have the game was awesome, he scored at the end, won, and off to home. What we'll do is we'll convert this into a document term matrix, and then we'll use the toArray method to build our data frame and see what we have for our test text document. Okay, the first thing we'll do is use the transform method on our vector object, on our count vectorizer, and convert this object into a document term matrix, and I'll save it in a variable called test text document term matrix, and that will be equal to our vector object, our count vectorizer, and then we'll call the transform method vector.transform, and then pass our test text. So here we have trained our model on the 3x7 sparse matrix as we have seen previously, and all the words that it doesn't know will be dropped. For instance, this awesome, was, game, scored, all of those, they will be dropped, and the number of features will still be maintained. So we have 7 features. Our model has 7 features, so the number of features will be maintained. It won't be different. Even if we have a bunch of words here, the number of features will still be maintained. Okay, that's an important concept. So when you try to make a prediction, the number of features must be maintained. So the number of features in your training and testing dataset should be the same. So once we have our document term matrix, we can convert that into an array by calling the toArray method. That toArray, okay, and run it. So we have a 4x7 array. So 4 represents, right, the number of documents that we have. We have 4 documents, so 1 for each, and the columns represent our features, the 7 features. So let's convert this into a data frame. So pd.data frame and then pass our array object here, and then for column names we'll pass the get feature names method that we used before. So we'll pass this, Command C, paste, and then paste it here, Command V. Let's run it now. Okay, now we have our 7 features, and then it will check each of our documents. Test text, let me type it here, test text. So if you take the first document here, which is represented by row 0, so the word soccer and go are recognized, so and they appear once, so we have a count of 1 1 1 1 for those, and don't and just will simply be dropped because those are not recognized in our model. And similarly, if you take the third row, which is our third document here, none of the words are recognized by our model, so we have a count of 0 for each of our features. Whereas if we take the last document here, only one word is recognized, which is the word home. Home has a count of 1, and all the other words are dropped. Okay, so what we have done in this model building is we have learned the relationship between each of these features, right? We have learned the relationship between the 7 features. And if we pass any new word, since we haven't trained on those new words will be dropped. Okay, so this is the basis of text analysis. What we'll do in the next lecture is consider a data set which consists of spam and ham messages. Spam and ham. Okay. Ham basically means not spam. And we'll analyze the data set, convert it into a documenter matrix, we'll build a model, and then evaluate how our model will do. Okay? On differentiating spams from ham. For that, we'll be using a dataset by University of California. So if you go to this website and then click on the data folder link here, you'll see an SMS spam collection zip folder. What you can do is you can download this zip folder and then unzip it where your Jupyter Homebook is located. Okay, and then we can simply use the read CSV method to grab the contents, or you can simply use the file I have provided. I have saved this file as smsdata.tsv file. You can simply use that file, or you can go to this directory and then unzip this folder and place it where your Jupyter Homebook is located. Okay, I'll leave the link in the lecture note. Thank you everyone, and I'll see you at the next lecture.